Hello and welcome again here for our training, Production Assist and SketchUp. Today we will having a look on how to use Production Assist in SketchUp. We've been updating the SketchUp plugin for the latest version quite a lot. You now have a library for trusses in there. You have more menu commands in there that you can use. And maybe the coolest feature in there is that we partnered together with AluVision, and AluVision updated all of their components that they have in the 3D warehouse, so that basically when you draw a booth with their components inside SketchUp, you right away can do a structural calculation for it that you can give to a trade show venue for verification, or that you can send to us, Production Assist, for our in-house engineering office, so that we take over the reporting and liability and basically create the calculation report for this. Production Assist is available for SketchUp 2024, 2025, and 2026. There is no difference in functionality about this, so it doesn't really make. Oh, wait, do you, you're hearing me, sorry, I just didn't see the microphone working. Sorry, that was interrupting me. So it doesn't really make a difference which SketchUp version you are using. Basically, all those SketchUp versions are supported. The first thing that we will do in the training is having a look on how to install everything and how to set up everything. Then we will have a look on basic calculations in here. What are the limits of Production Assist? So how accurate are the calculations that you can do with Production Assist? Then we will having a look on a small Truss workflow, so how this will work. And then we will move over to the AluVision components and build a complete booth, including a structural report that we can share with a venue. Let's start with the installation. The installation is actually quite simple. So you just need to go to the webpage productionassist.com. And in here, you can click on the download button. Wait, it's in German. Let me switch it to English so that you have it in English in here. And depending on your platform, either if you're on Windows or on Mac, you need to download the desktop application and you need to download the SketchUp plugin in here. So when downloading the SketchUp plugin in here, it downloads one zip file. And if you're downloading the desktop application in here, it downloads one DMG archive. If you do the same thing on the Windows, it will be an installer that you download in here. We don't need the desktop app because the installation of this is basically pretty much forward. It's more about the SketchUp plugin. So the SketchUp plugin in here is a zip package with this. And if you extracting this in here, you will see it contains two folders. One is the SKP24, basically the RBZ file that will be loaded into SketchUp as an application. And the other thing in here is the Production Assist library, which will act as the library for trusses and stuff in there. You also can download it from the 3D warehouse. We're currently waiting for the approval. This takes some time. So basically, you can both load it over the 3D warehouse for the extensions or download it directly for our webpage. Where you download doesn't really make a big difference with this. The only thing is we have full control of our own web page and when we release bug fixes and new versions. So that's why currently it's only available on our web page with this, as we are waiting for the approval from the SketchUp team. The installation itself in SketchUp is pretty easy. So what you need to do is you need to click on the extensions and you click on the extension manager on top of here. And it brings you a dialog that looks like this. So in here you see, for example, I already installed the AluVision exhibits and events in here, so that I'm using this in here. That is also needed to draw the AluVision components later. And I already installed the Production Assist thing in here. If you don't install it from the 3D warehouse, it will tell you that it's not signed and it will not have an icon, as this is only available for extensions that you directly download from the 3D warehouse. Again, that's also an option. Just in here, it's easier to show it like this. So the thing that you now then need to do is you click on install the extension. A dialog pops up, and then you basically just navigate in here to the SketchUp, select the RBZ file, click on open, and then it automatically installs it in here. An important thing, and you will see it in my file in here, I already had a Production Assist version installed, which means I need to restart my SketchUp in order to get everything properly working. If you install it on the first time, you don't need to restart. I will quickly restart. So I end my SketchUp in here, and wait, let me quickly disable this in here. And start it again. Oh, it started on the other screen. So I use the simple extension in here and have now started my Production Assist. So when you have started it, basically the most important part in here that comes with Production Assist is in here, the new menu bar in here. This menu bar brings specific features that allow you to use the tools in here. So for example, there's a tool with magnets. And then if you click on it, you can use the magnet tools. There's a tool to insert load. There's a tool to insert line load. There's a tool to insert area load, wind load planes, drops between hoists. We will have a look on all of these functionality later a little bit in here. Maybe an interesting thing, if you click on here on this button with the question mark, it will open the browser and will show you the SketchUp documentation on how to use it. So that's a good thing to always get some information if you feel stuck, to look it up in the manual. The manual is available in multiple languages, for example, English, French, Italian, Spanish, Turkish, Japanese even. So there's quite a lot of languages that we do support and where you can read how to use the software. The next thing that we need to do in here to come to a simple file that we can use. Wait, let me quickly mute this guy in here, is to install the content that you can use with with Production Assist. In order for this, you use the component window in here. And in this component window, you add a local library in here with this. So if you click on this, you go in here to the downloads. And in here, wait, let me double click in here. There's the Production Assist library. And you open this, and if you open the Production Assist library in here, it has the components for scaffolding, it has the components for trusses in here, and the component for hoists. In order to get a quick success in here, I will show you real quick how to calculate a truss, because we also use this example to actually explain you how accurate calculation in Production Assist are. So in order for this, I click on the trusses, I use the Prolyte trusses, and I click on H30V, which is like a general truss in here that you can use. And what I'm doing is I'm using the black truss in here. I copy it into the drawing, and now I have my first truss inside the drawing. These trusses in here, they have different tags in here. So the most important one is the truss snap tag. So if you're doing this and hiding it, it allows you to rotate it a little bit easier. So on this, there is a specific truss snap in here that you can show and hide with this. There's also a tag for the tubes. So for example, in the tubes in here, and you only want to see the snap, it's like a simplified view that you can use in here. The truss wire is basically all the tubes and bracings of this truss. And the most important part, which will be actually used for structural calculation in here, is the middle line of the truss, and in together with two magnets that will be used for the snapping functionality that we will show you. So those magnets allow you, if you click on one truss in here, to activate the magnet tool. select it, and you see you have it attached to the mouse. And then, for example, if you hold the Alt key or the Option key once, you basically can use it to duplicate the trusses. So really easy. You can align them and add by one truss in here, like a truss run, and create the truss that you want to calculate. If you click Options again, basically you will copy this truss. So selecting it, blue, which means just moving it. If you select it and copy it, it becomes green, and then basically you're duplicating it like this. In here, we have our first truss run that we are using in here. And the next thing that we want to do is we want to attach a hoist to it. So for this, I go back to the Production Assist library. There is a folder called Hoists. I insert this inside the drawing in here like this. So this is a point that goes into the roof. And I do activate the snapping functionality, click on it, and wait. And then you see I've attached it to the mouse. And then I can snap it to the truss in here. It automatically snaps to the center of the truss. If I hold the Option key again, it will automatically make this green, which means I will duplicate it. So for the sakes of consistency in here, I just go into this, select it, and now I have 2 times inserted the hoist in here with this. I end the tool, I delete the one motor that I don't need, and now I have everything in here for my first calculation. So in order now to turn this on, I need to click on the Production Assist Think button in here. So it's the Production Assist icon with the small green OK button. So if I'm clicking on it, it will start the calculation in here and read this into Production Assist. And you will see it directly gives me the option in here that it says load has no weight. So there is an error messages in here that the motors don't have a weight assigned to it. And I do see the reaction forces of these 2 hoists in here. As it's kind of symmetric, 0.4 kilonewton, that about 40 kilos, actually go into the roof in here. These overlays that you see in here can be controlled by the overlays. So there are 3 overlays that we have. So one is the error overlay. So if I turn this on and off, it will not generate me these errors anymore. I have the results overlay, the attributes overlay, which basically show me the attributes in here. So the workload or the capacity, the force that we actually do apply on the 2 hoists in here. And a little bit later, when we're showing this, there's a Production Assist results overlay that will also show the results.
Moritz, hi.
Oh. Hi, Lotte. Yes.
Hi, sorry, I have oh, wait. Yeah, okay, sorry, we were together in a meeting room. I have a small question, and I don't know if it's going to be possible to fix it, but I see your design very well, but I don't see, I think it's because you have a very large screen, I don't see the icons or the text very well. And sometimes it's a bit difficult to see what you're clicking on. So I don't know if you can make the pop-ups bigger or not. I just wanted to check. If not, we can follow.
Yeah, wait. That's a good point for you. Let me quickly change this, and let me change it.
I'm sorry for disrupting.
Is this better?
Yes, so the screen I could, perfect. Yes, thank you. Thank you so much. A lot.
So then that's good. Then let me quickly quickly arrange the new icons in here with this. So sorry for this, but I think that's something that is true for everybody. I can look in here. Maybe I can. Yeah. Oh boy. Look, that looks good. Then last thing with this in here. Perfect. I will move some part of it to the other screen in there, just that we have the one that I have in here. Okay, sorry for this. So now with the icons, so the button that I used like before in here was this button in here with the magnet that is shown that you can use for this. That was the thing actually that we use to click on a truss in here and then with the Option key to duplicate it. If I'm doing this while I'm still active in here, you will see actually it will also work with this specific thing and will change the reaction force. At any time, I can click on the stop synchronization, and you see it turns off the synchronization. It has some overhead in SketchUp. So if you then want to start it again, basically you just click on the green icon, and then it starts the calculation again, and it synchronizes the moves with SketchUp in here again. So now it's a little bit easier to do. I hide the error messages for now, that we just see the two reaction forces in here. So the next thing that we have a look on is the user interface of Production Assist. We will look at this a little bit more, but just now, in order to see the results, I'm clicking on the user interface button, and this will open also on the other screen. So I make it a little bit smaller, that it looks like, will look like this in here. So I click on cancel, and in here I have the user interface of Production Assist. There's quite a lot of things happening in here for this. So we just focus on the main thing in here because we want to go to the navigation. And in here, we can click on the influence lines. And when I move this in here, there is a show combined deflection DU. And if I'm clicking on this and moving this out, I will see that it now shows the deflected shape of the truss in SketchUp. On the same way, for example, I can tell him I can want to see the workload, or I want to see the bending moment in here. All of those are basically structural information that I can use to see if a truss is overloaded or not, or when we talk about the AluVision things in here that tell me if a truss in here, if a frame is overloaded or not, or how many connectors I need to set everything up. Last thing in here for the simple thing, how it actually works, is that we use the point load tool in here. And if I'm clicking on the point load tool, I actually now can select one of the truss. I see a small highlight beam in here, and then I click again. Then it asks me which weight do I want to assign in here. And for example, I can say 80 kilograms with this, pressing OK, which will automatically add a load in here that is 80 kilogram. And now every time I'm moving this load around, for example, not like this, I want to move it. So in here on this, it will update this. So that's the way how Production Assist works. So all the changes that you're doing basically are always done automatically, so that it's really easy to see what are the consequences in here and how you can use this for structural calculation. That's on a real simple level the way how it works. So you build your structure in SketchUp, you activate the syncs, and then you show the calculation results and check if you want to do it like this or not. Before we now dive a little more deeper into this, and now is the part where I tell you don't do what I'm doing, we will having a look in here on the actual parts of this, on how accurate our structural calculations are. In order for this, I disable all of this again, so just that's a little bit more easy for me to see. And now what I'm doing is I'm moving this motor to the side. Wait, not with the rotation tool, but with this. So moving it to here. And this motor I will move to here. So just that I have 2 points in here. And then what I will do is I will duplicate this. So I will move this and duplicate it so that I have 3 motors in here with this. Let me quickly look if everything was correctly. No, that was not good. So let me delete this quickly. Click on this in here, select the snapping tool, select this again. That was wrong selected. I want the motor in here. Yes, like this. Clicking the option key so that becomes green. And then I put my motor inside the middle. I also don't want the point load in here anymore. And then I download it like this in here. It's not perfectly in the middle. So let me quickly move this a little. I don't want to rotate it. I want to move it. So move it in this direction. So like this. Yes, perfectly. So now when we are doing the calculation in here like this, I actually see that I have a distribution between 3 points. So typically about 66% go into the middle if you have 3 hoists, and about 18% go into the right 2 things. In other words, almost 3 times the load goes into the middle, but and 1 time goes into the outer side with this. So when doing this, actually, we see quite wide. It's quite easy to reproduce these results that we want to achieve. When we now go into Production Assist and show the deflection shape in here again, and I will make it a little bit easier in here with deflection shape. Wait, let me do this on the other screen, just that I can here show deflection figure. So I see the deflection figure. You see, oh, it's not really symmetric in here, so it's not perfectly leveled. So let me move it a little bit into the right direction in here with this. So from here to here, so that it's, now it's a little bit better. It's still not perfect, but it will do the job in here for the first things. So now what I want to show in here in order to come to a solution, and for this I make this a little bit different in here with this so that you see both with this. Let me hide this in here, is I move the Production Assist palette in here with this, and I select the motor in here. And this motor, when I'm that's not the motor, when I'm selecting it, I'm getting in here the object properties for this. I've hidden all the other things. We will have a look on this a little bit later. So if I'm now going into here, I can click on support. And in here, I can go into the chain shorten settings. And there is something, and I set this to centimeters or inches, is fine, with this in here that allows me to move the hoist up and down. So basically, if I'm hitting this button, you will see that at this specific point in here, it will move the point up at this side. And because of this, it will automatically move the middle one out of load. So depending on the actual leveling of this, and for example, if I'm only doing 5 millimeters in, that was a little bit too much, millimeters, boy. So let me quickly reload it. Yes, now it's in millimeters with this. And going to support, going to the chain shorten settings in here, setting this to 0. When I'm now using it the millimeter, so every time I'm changing the high in here a little bit, you're seeing I'm distributing load from the outside in here to from the middle to the outside. And that is basically something that is called leveling with trusses. So if there is more than 2 hoists on a truss run or more than 3 hoists on a frame, then this is a so-called structural indeterminate system, which means that the actual reaction forces on all of these are always based on the right leveling of the structure. So if you hang it a little bit offsetted in here, it actually will change the reaction forces of the individual parts in here. And this is also what is happening on the frames from AluVision, for example. So if you don't make probably sure that they are all on the same level, you will have basically different calculation results with this. It is more easy to mess it up with hoists, but it basically also applies to the standing frames. You also can hang the AluVision frame, so that's also a thing in here that is important to know. That the chain shorten in here, or basically the leveling, has a big impact on the actual calculation of this and changes the reaction forces, for example, on motors, but also the workload quite a lot with this. So my question in the round, is there a question about this?
Not at the moment for us. I think we're...
That's perfect. It's just the understanding part with this. So just to summarize, so if you're doing a calculation with Production Assist, it is not a smart tool that knows what you are doing. So it's like a hammer. So you can use it to solve a really specific problem. And in there, it's really powerful and can do all the things that you need. But for example, the leveling thing is a fundamental part of the structural calculation. So if you don't replicate the settings that you're doing inside the structural calculation, you will not be able to reapply this inside the actual calculation with this. I will quickly just change the text a little bit with this so that I have a little bit more screen. I think, is this still acceptable for you? Do you still see the icons?
Yes, for me it's okay.
Perfect.
Yeah, thank you.
Then perfect. Then we do it with this, then I have a little bit more space with this. So that basically is the way how this works with the different things in here and with the trusses. We will make this now a little bit more extensive in here, that you also see the other features with this, that you know that they are there, and then we will step over to the AluVision with this. So for example, if you're having a corner element in here with this, you can use this corner element in here, move it into the drawing, and select the snapping, move it into where we have it in here, move it into the drawing, select it with the snapping tool, and then when you assign it, also this works. If you press the shift key, it will basically rotate it around the different things. So it can be either inserted like this and then clicked, or if you click again on it, hold the options key, for example, you can also insert it like this. And every time you're doing this in here, actually it will update the calculation for this and then allows you to do more complex things in here. So for example, if you're using now in here a longer truss in here, insert this, use the snapping tool in here to snap this truss attached to this. Now we're using the, where do we have it? The hoist in here, clicking on it. I want to copy it, hold in here to the Alt key. So if you're now doing this, it will actually have the option in here that you now can calculate it like this. And when you now click on view, we want to make this a little bit larger in here with this. Sorry for this view navigation. Perfect. Now I have the navigation in here as well. I can click on here and click on Show Combined Deflection DU. Then you will see it has the deformed shape for all of these elements in here as well. The library that comes with Production Assist is for Prolyte currently. We are currently in the process of adding more and more of these trusses that you can use. So that actually is a good starting point to use them in order to get the full experience with this. Now, before we go into more details with this, we also will have a look on the AluVision parts with this. For this, I will start a new drawing. So I will delete everything. I will stop the synchronization in here so that it's not always running in the background with this. And now I'm starting with the AluVision frames in here. So the AluVision frames, when you're using them, you need to have the AluVision component installed, and you can click on the AluVision exhibit parts library. If you're clicking on it, it will open in a warehouse in here, and there's basically all the AluVision materials that you can use inside in here. So we will do an Omni 55 beam. So I'm clicking on it. And in here, there are several rounded stuff in here. There's a lot of different things that you can use. We want to have the standard frame. And when I find the standard frame, this is this here, the A3 frame. I can import this in our SketchUp module. View. Sometimes a little bit challenging to good camera. We want the isometric view. Oh, wait, where is this? Where did it insert me the thing? Camera, isometric view. Okay, let me start a new file. I think I messed up the view. So again, let me do this again. AluVision part library, Omni55, using the A3 frame in here, download it into the thing. Yes, now I have it attached to here. And now I see that there is this frame. The cool things with the AluVision components is that they are dynamic components. So if you click on it, you can click on the dynamic components, and there are the components options, I think. Yes, and in the component options, you can select the width and the height of this specific element. So for example, the height is currently 2408 and the width is 992. So that is totally fine. We let it like this. We just want to know that there is the option. So if you now want to duplicate the specific thing, you click on it, you activate the move tool and duplicate move it in here. A really important thing for Production Assist that you actually can calculate is that you're using the snapping functionality from AluVision. The different frame parts in here really need to align. So if I have these two things in here, I can use the snapping functionality in here, use grab points to connect parts, click on it, and then I got these blue bubbles in here. These blue bubbles allow you to select which other bubbles you want to align to. So it's easiest seen when you actually do it. So I'm clicking on this bubble. And then when you look on here, now all the other available bubbles are available in here. For the best performance, it's always good to have the second click on the other part that you want to connect, because then it will disable all the bubbles on other components that are not available for connecting anymore. So it's a two-click tool, so 1 and 2. Sometimes when you can't click, you need to change a little bit the view in here. You click again, and then in the end, you need to press the Enter key, and then it perfectly aligns this so that these two things actually do work together and that they form a connection in here. This works to the side, but this also works when you're moving it up. So if I'm now wait, I don't want this, I want the move tool. So if you're duplicating it again, we click on the component options and now change this to be a little bit smaller in here. For example, to be 148 with this, you need to click on the apply button in here. You have now the smaller frame. So now what you can do with this is again clicking on here, selecting this 1, 2, 1, 2, pressing enter will automatically slap this in here, and then duplicating this again, selecting the snapping tool in here and do it like this. 1, 2, 1, 2. Then I have basically the first part of my wall in here. So the next thing that we will need is a corner in here. So the corners you need to use again from the from the AluVision exhibit components. So you click on the AluVision exhibit parts component in here. And when you're now doing this in here, there is something that is called corners. And then there are different corners. So there are T corners that you can use. There are C90 corners, so for 90 degree. There are fabric corners that you can use. For our stuff, we right now use a fabric corner in here. So I'm importing this into my document, clicking on it. And now the challenge is a little bit more to select the right height with this. So I can either use the one that I have in here. Now I actually need to do the math. So it was 2405 and this was 148. So 2408 plus 1440, 3902. So I'm selecting this. Okay, maybe it's this one. Doesn't look too bad. So maybe this works in here. Now I have my corner element in here like this. Again, I need to use the snapping tool like this. So I'm clicking on it again. So now it shows me where I actually can connect to it. So one click in here, one click in there, one click in here, one click in there, pressing enter. now you see it automatically has inserted me correctly. I don't selected the right height. You see there's still one option in here, so I need to make it a little bit larger with this. So I'm applying this, and then I'm having a little bit an overlap in here with this. So in order to snap this again, I need to move it to the side, select the snapping tool again. Wait, move this out of the way, select the snapping tool again. That was the wrong snapping tool. It's always move the one that you're selecting. So snapping tool, this should be connected to this, and this should be connected to this. Pressing enter, and now it's perfectly fine in here. An important part with this is when drawing this, you need to make a little bit clear on how you want to insert it. So that's an L corner still, so it doesn't have connection option on the other part with this, but that is really important for us that this is also aligned so that you don't make up the connections, but really use the connection tools. A little bit later, this will become more clear when we actually then do the calculation. We will now really quickly finish this so that we have a tool. So I'm selecting all of this. I'm duplicating this with the Alt key. And now I also can snap multiple things at the same time. For this, I'm clicking the snapping tool in here with this, selecting this thing, one, and going into here, and then say from here to here. Okay, enter. And then when zooming out in here, you also see that you have this wall aligned to this. So you already see we want to make it a little bit simplified with this, just that we get a really simple calculation on the first place. We will now do just a really simple rectangle. So I'm duplicating this again, selecting the snapping tool in here, say I want to snap from here to here and from here to here, pressing enter, and it creates me this. So next thing, duplicating this in here. Duplicating this in here like this, selecting the snapping tool again. Now I need to rotate a little bit my view that I get the good things. So clicking on here, and then here, on here, pressing enter. Okay, so now I have almost all the things that we need in order to calculate. The only thing that is missing in here is the actual connection between the different things. And in order for this, you need to insert the different connectors in here. So if you click on this, there is in the AluVision the thing, click on connect. And if you click on connect it, it will automatically find the connectors in here. So it will all add the 64 new connectors. You see in here, when you move this a little bit, that it adds them so that they are connected in here. These connectors are really important so that Production Assist actually can calculate them. So I'm moving this a little bit to the in here to the side so that we have this. And the next step is actually loading this into Production Assist. So when I'm clicking on Start for Production Assist with this, it notified that there is the AluVision components and it wants you to enable the use floor as a support. I'm clicking on yes, and then it automatically updates this and loads this into Production Assist. So now it becomes a little bit special. So if you open the user interface from Production Assist, you will now see that actually there is an active calculation. So if I'm now clicking on Show Combined Deflection DU in here, you will see you have already the connected shapes of the different models in here inside the calculation for this. So the middle lines, the blue lines are actually the deflected shapes of this. So don't worry, those connections that you have in here, this is scaled. So it doesn't really look this bad as it's shown in here. So if you go to Production Assist and you activate the renderer in here again, you need to click on the plan view as well. It also shows you this in Production Assist in here. And you see the maximum deflection of this in here is 0.9 millimeters. So in here, this 0.2 millimeters are scaled so that you can see it. And this basically explains why it looks so bad in here. On the next thing in here, what you are doing, let me quickly move this to the side so that we see all of this in here like this, so that we have the 3D model of Production Assist. You can click on the show workload. If you're clicking on the workload, it will basically show you how much these AluVision frames in here are loaded and how much it is deflecting. You can't use it if it's above 100%. So a lot of the calculations that you're doing for the Production Assist side in here is that you actually check that the workload of this is below 100%. Just to show you what would happen if you would increase this, I now use the tool for inserting loads in Production Assist. Click on it. And now when I'm clicking on here on one of the AluVision frames, I basically can add a load to the AluVision frame directly. So what I will do is I will click in here, add a load, and I will do like a 500 kilo load. And if I'm now apply at the red highlighted point of 500 kilos, you will see it is still okay. So it will not break with this in here, but you are at 65% workload. So if you're selecting this object again wait, I want to select it. If I'm selecting this object in here again, and for example, change the workload to 1,000 kilos with this, you will see now it's overloaded at this position and gives you basically that this will not hold if you put 1 ton at this position in here. If you hover this thing, it will basically tell you what is overloaded in here. So you see, it shows you the capacity for the corner profiles at 43% and the default Omni profile in here at 55%. But the actual problem in here is the quick tighteners. So basically, the problem that this has is not that the frame will break, but the quick tightener actually connecting these two things will fail in here. You see right now, and you also see it a little bit in the deflected shape in here, that basically when you use the click on connect button, it will add 2 connectors per each side of the frame in here for the calculations. So if you now would duplicate this connectors in here, you actually would be able to withhold this 1,000 kilo charge in here, that it doesn't tip over. Normally, that's not the way how in production or how AluVision frames are calculated, because you don't put 1,000 kilos on one single frame in here. So typically what you do is that you have the frame itself, but in order to do this, you also need to use some kind of horizontal replacement load in here. So I will delete this for now. And as a next step, we will look into the settings that you need to use for this. We already learned inside the user interface that there is the influence lines. The actual calculation settings in here are coming from the load combinations in here. So if you're clicking on the load combinations, there is the so-called wind load type. And there is 2 things that is important for us. One is the actual wind load calculation in here, or the actual indoor calculation. So with AluVision frames, basically there's 2 things that you need to calculate depending on where you are. So if you are in Germany, or for example, in a lot of the Spanish trade show venues, they do apply a specific flat fare for a horizontal load based on the height of the structure. This is set by this specific thing. So indoor trade show floor basically means that it applies a specific wind load to the truss that it needs to the frames that it needs to withhold. If you are not inside a German or Spanish trade show window, you can apply the EN 7087, which basically tells you that you need to apply 2.5% of the dead load to the structure where they are. So if I'm activating this thing in here, it will automatically apply 2.5% of the dead load as vertical load in here. So let me make this a little bit larger in here, clicking on here, that we see this in the bigger one. It will activate the settings, apply horizontal load based on total load, which is 2.5% in here. Okay. And now you will see if I'm pressing the OK button, it will move a little bit to the side because some parts of the truss are actually moving it to the side. Based on the wind angle, which is in here, you can change it. So currently it comes into this direction. So if you change it to 45 degree, you will see now it's moved into this direction. Or if you change it to 90 degree, now it goes into this direction. So you can basically change the angle in which the horizontal wind in here is applied. And you see this 2.5% is not that much load with this. So if you click on the rigging and in there on the calculation, show calculation overview, it gives you an overview about all of the loads inside the element in here with this. So for example, in here, the frames weight 9.6 each, in total 74. So in total, there is 2.5% in 253 kilograms of load in here, and 2.5% are like 2.5 kilograms. So this is not really a lot in here, but it's one starting point that you can use for the calculation. This kind of wind load approach or horizontal replacement load that you have in here can be used for all venues which are not German or Spanish trade show venues. So for example, in Belgium or in the Netherlands, these calculations, they are totally fine. So you see when you're doing this in here, the actual workload of this is still at 5%, so increased a little bit, but not by quite a lot. So as a next thing, what we will do is that we actually do the same thing now for the indoor trade show workflow. In order to do this, I click on the load combination settings and I set the indoor trade show workflow load on here. And now when I'm doing this, I see that it shows me the wind pressure at a specific height. So and you see in here at a specific height, so at the first 4 meters, the force is 0.125 kilonewton per square meters. And below, above this, it drops to 0.06 kilonewton per square meter in here, and basically shows you this thing. So if you now press on OK, you will see, well, nothing has changed. This is because you still need to define the actual area that gets affected by this. To do this, you need to use, now let me move this to the side, that's a little bit easier to see. You need to use the wind load button in here. So it's a small wall with a wind load. You click it, and then when you click in the drawing in here, it allows you to draw a polygon like this, where you basically can tell them how this is cluttered in here. If you're finished, I think double clicking is the right thing. Was this double clicking? Wait, just let me look. No, it was enter, I think. Sorry for this. So let me do it again. So I click on this button. 1, 2, 3, 4, and enter. No. Double, is it double clicking? Wait. No, I'm surprised. View, navigation, view, navigation, view, scene tree, view, scene tree. Did I enter it? Sorry, let me do it again. So selecting this. So 1, 2, 3, 4. Now it has worked. And now when you look into this in here in Production Assist, it will add you like a gray area in here, which is the covered area for the wind loads. So if not all the areas are covered, that's basically how you would do it in here with this. So then as the next thing that you do in here, you do it again for the other sides. You only need to do this for the 2 sides of it. So that you have both of them covered. And if you now seeing this, you now actually see that it moves to the side in here with this. So now you have also a quite larger wind load approach in here with this. You see, now it jumps to 97% use case in here, because now there's a way more vertical load. So remember before it was like only like 2.5%. So if you now go on rigging and click on the show calculation overview, it will show you that actually now 1.7 kilonewton need to be applied to the structure. Just remember before the actual force was 1.5 kilonewton. So now it's 1.71 kilonewton. So it's much bigger force that is applied to this in here. It even gets more worse. So right now we are inside a trade show wall. You can use the exact same thing in here to be outside. So if you click on this in here and you click on the load combination settings and you click on the, wait, let us run the dialog, then it's a little easier. So wind load settings, you can click on outdoor Eurocode. We can say, hey, we are in Belgium. We are inside the area 25 meters in here, so 25 meters per second, and we are inside the city and pressing OK. And if you're now running the calculation, you will see actually now it's overloaded. So now you see in here with this, you're at a 350%, and it's the quick tighteners which are basically failing in here if you're building this specific thing on an outdoor way and calculate this like this. Okay, then question in the round. And is there a question? No? Perfect. Then I will continue. So this was a really, really simple basically frame that we are calculating with this that you can use for the thing in here. And we can use it for, sorry, yes?
Moritz, I have a small question. Are CAD drawings are including die bond infills?
Oh,
these
can
are
you
not, our frames include infill panels. You can see it. Some of the frames you show the holes and others you don't
yes,
see them.
yes.
But those are not calculated in this case. It just calculates the frames, correct?
It just calculates the frames and it does not use the inside in here as a wind load plane right now. The reason for this is that depending on the way how they are built up, you only need to mark the 2 frames in here. So otherwise you would have 2 times the wind load in here. So currently you need to mark up the wind planes yourself. You see, with this, even if it's formed by 4 sides, I just mark up the left side and the right side, and these basically get the full wind load that you need for the calculation for this.
Yeah, and does the weight matter of those panels? Because sometimes you have panels one side, sometimes you have panels both sides.
Yes, they do matter a little bit, but it's not that much load compared to the other part in here. So that's why currently it is not in there. I think currently it's only using the frame load for the calculation.
Okay, thank you.
Okay, is there another question about this?
Hey, another question. So I just wanted to see if the calculation system will still work if we're like patterning out frames instead of using the actual node connectors. So just using that SketchUp normal, point-to-point locking system.
Yes and no. So if you do a good job with this, it will still work. I will quickly show you what is happening if you're not aligning this correctly. So you can use the normal snapping stuff without any problems. But in order for Production Assist for the AluVision plugin to insert those connectors, the geometries need to be perfect. And it's only the position, basically. So if you manage using the normal, like when you move in here and you move it with these points in here, to manage to click it on the right point, everything is right. But if you now click it, for example, on this point so that it's overlapping in here, it's a little bit forgiving. So in here, it still would work with this. Wait, let me quickly change this in here so that it looks a little bit easier. You still see it still can do this connection, but at a specific time. So if you move this to way a little bit too much away, it will not be able to recognize this connection anymore, and then the calculation will fail, for example, in here. So it is really good to use the AluVision snapping. It is not required. So if you do it like this, it still can do the calculation and snap everything together, but it needs to be accurate. We jump into this a little bit more. Why is it like this? And give you a thing and how the actual calculation works with this. So as long as you actually pay attention to this, it will work. So for this, I need to have the text again. So where is my tech window? No. Sometimes a little bit, here, the text. So if you look on here with this specific thing, there's specific text. And I will hide the different things in here with this, with the frames. And wait, where's my Production Assist window with this? Wait, let me show my Production Assist window. Just want to, wait, I could also want to hide the workload and the DU in here. I want to hide this. I want to hide the infill. No, that's right. Connectors here. I need this. Yes, perfect. And this. And the Velcro. Why is there? That's the wind load area. So let me quickly delete also the wind load area in here. Perfect. Are you seeing those lines in here?
Yes.
So those lines are basically used to calculate it. So all of the components from AluVision have the lines so that they are in here, and we store the cross section that has been used also into these lines. So as long as the connectors and the different frames basically form this connected model in here, we can calculate it. So that's also how you would create your own components with this. You see, for example, in here, there are small gaps which are allowed, but they are small. So it's like 5 millimeters that are allowed, and then we will silently fix it. But if you are not snapping them correctly, you will have a hard time with this. So in other words, so you can use the normal connection things from SketchUp. This works pretty well, but you need to be accurate. Does this answer your question?
Yes, it does. Thank you.
Okay, up to the next step in here with this. So right now, when we are calculating it like this, we are able to calculate the structure in here, and we are able to calculate also, I've deleted the wind load I'm seeing, so let me just add one wind load plane in here again, so that we have it again into this thing in here. 1, 2, 3, and 4, double clicking. 1, 2, 3, 4, double clicking. Now it's in here. Perfect. So now it's pushed to the side. What we've been using so far is the option. It's still using the wrong wind load. We want to do this with the indoor trade show floor, pressing OK. And then it's not overloaded. So then it's an 84% in here. So that's all good. We now need to calculate the ballast for this. So we want to know how much ballast do I need for this. So the simplified floor approach basically tells Production Assist to calculate the floors in here so that they are shown like this. But if you want to do ballast calculation, it makes a little more sense to define where you're actually attaching these things to the truss. So in order for this, you click on the load combination settings in here, and you disable the setting use floor as a support. If you disable the settings, you will see it will not longer calculate because it doesn't know how this is supported. And now you need to do a little trick in here. So you're clicking on the new object in here, you're clicking on the symbol, and this will download the symbols from Production Assist in here. So the thing that you need is the so-called ground support attachment. If you're selecting this, it will insert a small blue circle, which will be used as a support. So if you're clicking this on the different corners in here, you basically tell him at which points this frame is supported in here. And if you do this with the 4 points in here, the 1, 2, 3, and 4, it will show you how much force is applied at this point to the ground. So to see this, you select the 2 or the 4 ground supports, and then here you click on support and scroll down to the show result in 3D. And if you click on this, it will basically show you how much force. Wait, let me quickly select them that they're all rotated in the same direction so that I do change the rotation in here, 0, 0, 0. So I see that basically on the left side, the reaction force is 0.4 kilonewton, and on the right side, the reaction force is 1.7. So basically, this currently means that it's tipping because it actually needs something that is holding it down. So in trade shows, you normally don't screw to the bottom. It's possible. So if you would screw it to the bottom, you would need to make sure that this connection is in here. But in normal applications in here, you now would to calculate how much ballast do you need. For this, there's a real simplified approach for it. You click on rigging, and you click on special operations, and there is the calculate ballast. If you now run this thing, it will basically calculate this structure from all the different angles that are available and calculate the needed ballast in here. So now it calculated them, and if you now click on the actual thing in here, wait, that was too much. So on one of the things, you will see that this now has a positive number in here, and that at this position, if you go to the structure, it has added 80 kilograms of weight. So in order for this thing to not tip over in German trade show venues, at each of the corners, you would need to put in about 70 kilos in here. So for this simpler frames in here, this kind of ballast calculation is quite easy with this. I show you one example for one of our engineering offices where it's a little bit more challenging. Let me see this if I found something really quick in here with this. Yes. So I'm opening it. So that is from one of our clients, a calculation with this in here. And because the actual wall is very, very thin and is deflecting quite a lot, you see how you need to apply the ballast in here that it's not tipping over and not breaking. So especially in German trade show halls, you need to have quite a lot of ballast in here with this. So Production Assist is a good tool to calculate this. We're using the exact same tool in our engineering office. But if you need help with this, basically the easiest way to get a quote for this kind of structure, so how much it would cost to be calculated by us, is just clicking on File, Request Check Structural Calculation, and then it shows you a quote for this. So for example, in here, in order to get the STEM calculation report by the Production Assist engineers, that would be 277 euros. Normally, this is same day delivery or next day when you order a little bit later with this. In either ways, we will contact you and then we create you the reporting part with this. But you also can create the reports yourself. And that's basically what we're doing in here as the next steps. So I already did the calculation. So I checked that I have calculated the right amount of ballast in here with this. I've checked that my truss structure is not overloaded. So that's at 74%. So the amount of corners that I have is totally fine. What I also could check with this in here is when I click on show floor loading, it shows me the resulting floor loading that I do apply to the floor in here. So this is also in the green area. So currently, if you click on the load combination settings in here, the floor capacity is set to be 5 kilonewton, which means that you can apply about 5 kilonewton per square meter. And you see in here, we are always below this value. So all of this would be fine. So in order to calculate now such a thing in here, you would choose a good looking angle of this. You click on File, you click on Create Calculation Report, and then it allows you to create a PDF out of it. There's a simple export and the advanced export available. We want to use the simple export. We don't need to prove the hoists as we don't have any. We didn't need to prove the drops as we don't have any. We want to add a table with the ground supports in here. We want to add the wind loads that have been calculated. We want to add the floor loads. We want to add the cross-section proofs. And we want to add the current view on the front page. So the only thing that I need to write in by hand is I need to select the project description and write in how I want my project to be written. So small AluVision booth. The question is how long this is. So where is my measuring tape? It's always good to write in. So from here to here, wait, where it is showing it. So from here to here. I'm stupid. Why it's not? So 2 meters. Sorry for this. So it's more 2 meters by 2 meters. The height is, and I think it was something like 6 meters or so. I have no idea. Now I can just select a background template so that it uses a CI. I click on background label, background in here, and press on OK. Now it will ask me where I want to save it. I want to save it on the disk, and I call this report, save it. And now when I'm doing this, it generated me a calculation report with this. I didn't fill out the project name and the location. That's why this is still empty. But it gives me like the document in here. It shows me the table of contents that I have in here. So what is part of the calculation? It shows me the program nodes in here. It shows me all the different loads that actually go into the calculation in here with this. It shows me the wind load that I've been calculating here for the specific things. And it shows me the different floor loadings for this thing in here. It will do all the math for the quick tighteners that you are applying in here so that this is not overloaded. It will do all the calculation for the actual bending moment that is used for these calculations in here, and then give me a complete table with all the materials that have been used for this FEM calculation. So that's basically the way how I can create a calculation report for this. You can change the icon in here for sure. You can also change the background so that it looks a little bit more in your corporate identity. And if you click on File, Settings, it will actually be able inside the project to give the project name, the company, so that all this information in here can be filled out and that it's not lost in all the things and looks really nice. Changing the background is really easy. For this, you click on Resource, you click on Labels and Backgrounds, and in there's the default background in here. You click on the Edit button with this, and then you click on the Plan View, on the 2D view. It shows you the 2D view of the actual program version in here. And then, for example, if we want to have, for example, another icon in here, you just can click on it And in here, you can click on the linked image and then import new image. And it allows you to import a specific texture in here. So I just generated this image in here. So I import this in here with this. And now I can select it inside my SketchUp application so that I can use it with this. Okay. Is there a question about this workflow so far? No? Perfect. Then I just did something that crashed my SketchUp. So I show one more example of a little more a bigger boost in here with this, just that you get an idea what is also possible with this. So if I'm opening this in here, löschen. So that's a boost in here that is a little bit bigger. So you will see that when you open this, it has also an LED wall in here assigned with it. So in order to calculate this, you just click on the Production Assist icon. Now it asks you again about the floor components with this. And then when you go into here, for example, if it says in here with this, it allows you to calculate this as well. So I've opened the thing in here, click on the Show Deflection DU, and now you see, for example, it's not supported all the way in here. So sometimes when you draw these things not too much down, you need to click on the load combination settings in here and move the floor level a little bit above. So a good value for AluVision in here is always 40 millimeter, which is 4 centimeters. And if you then click on OK, it will be calculated that all of what is cutting these 4 centimeters is basically calculated at the right thing in here. And then here you see when you look, it automatically calculated also the LED tiles with it. So if I'm selecting them, click on Show Calculation with this, they are part of the calculation and used as a ballast, for example, or just for a general load in here. So also these more complex calculations are possible. Okay. Then that's basically the first introduction and training into the SketchUp for Production Assist with this. Are there any questions?
Yes, Moritz.
Hi, Abdul.
Yeah, if we increase the number of tighteners, does this reflect on the results of the report?
Yes, definitely. Let me show you this in here in this element in here. So right now you see that there's 2 connectors on the actual thing, and you see that it's deflecting a little bit in here like this. I think it's a little bit easier visible when we are in here. Let me disable quickly the show structures with this. So when you look in here, we don't need the workload, then it's really visible with this. So right now it has this in here basically calculated like this. So if you now select this quick tightener and duplicate it like this, you will now see that it's now also using this quick tightener in the calculation. I think I moved it wrong, so now it has an offset that was wrong. That is what I meant about the accuracy before. So if I'm using this, and that was wrong. If I'm using, I don't want to rotate it, I want to copy it, yes. So like this, and I'm moving this down perfectly like this, and clicking, it will be used inside the calculation and will create another element in here with this. Wait, let me quickly read it in again. Yes, set it to 4 millimeters. Okay. Perfect. So structure is off. That's right. Show deflecting in here. And then you will see that at this position, there are now 2 connectors with this. So let me see if I can actually prove that this is there. So we need to find this, and here, yes, you already see it. So now you have one connector in here and one connector there. So basically, if I have problems with the integrity of the things, it's normally the connectors that fail more, that I start to add more and more of these connectors so that I make the connection a little bit stronger and reduce the pressure per connector in here. Does this answer your question, Abdul?
Yeah, thank you.
Okay. Is there another question? No? Perfect. Then maybe as a last thing, how do I get help? So typically, if you now rewatch the recording and try to do this yourself, you find that the recording can be quite helpful, but maybe you are stuck at some moment. So the easiest way to get help is to use our chatbot in here. So there is by default an AI that is helping in here, but you can, when you ask something, hi, you need to add an email address in here that we can talk with you. There's also the option then in there to connect you with an agent. And that's then basically our support team. So that's an easy way on how to get help with this. What you also can do is you can click on help and there is the online help with this. So if you open it, there's a documentation in here and multiple things that gives you a lot of knowledge that you can use in order to check actually what is going on and how does it work. The other part is that you can use, and that we highly encourage to use, is the demo request. So if you do have a question about something, just click on the demo request and it will show you the different dates in here. So for example, I want the 30-minute slots. It shows you which dates are still available to book in here. This is free to do, and we help you on this call because it's normally easier to help you via Zoom on this and to show you how it's done than to write 100 emails with this. So that's a good thing to get support for this specific product and to get special structural calculation questions answered. So with this information, I want to leave you in your evening. Thank you very much.